it kind of like today. It's not too crazy from yesterday. We're back to solving the equations. It's all student calculus. It's all the things. But of course, there's some twists to it today because I'm going to use some identities in some of these because you're going to have different trig functions in some of the equations. I'm going to maybe do a little factoring, that sort of thing. So I am going to skip a couple problems on your notes so we can maybe set up some on your homework and try to get you out of here with less homework problems to do over your 3-day weekend. Betty White told me to do that. Okay. All right, here we go. So first off, this is one of those, as soon as I see the squared, I'm instantly like, oh Lord, here we go. We're going to be in all 4 quadrants. It's going to be obnoxious. Nobody has the time for that today. We're going to do it with writing the answers the shortcut style. I'm just going to do it from that version just to show us again, okay? So obviously I'm going to add the 1. You don't need to see me write +1 and divide by 3. I know you know we're going to cancel this with a root. We got it. We're going to remember plus or minus, which is a small but critically important detail. I'm going to square root 1 in my head. I'm going to leave that alone. Normally I would think I should rationalize, but I'm not going to because remember that is a square root of 3 is on our special triangles. Now, plus or minus technically puts you in all 4 quadrants, but that's very obnoxious to do it. So I'm going to do it the shortcut style. I'm going to start in 1. Okay, tangent, TOA, opposite adjacent. And of course, this would be 2. I'm going to figure out the angle across from 1. You all know it, it's 30. And remember, even though it doesn't specifically tell you, you're magically supposed to know in the directions if it doesn't specify. You're going to give that in radians. So what's 30 degrees in radians? Pi over 6. Now, normally, for our coterminals, I would do all the multiples of 2 pi, a full circle. But I'm going to work smart here. I'm going to knock it to a single pi. Because if I add pi, 180, if I add 180, it toggles you into 3. Another 180 puts me back to 1, 3, 1, 3. This gives you all the answers for 1 and 3. So now, to save myself some work here, I need 2 and 4. So, all right, I'm going to draw it in 2, fine, whatever. Some of you probably already figured out without even having to draw the picture of the triangle, you're 30 short of 180, you're at 150. I'm going to put that in my radians. And then, of course, I'm not going to add the full circle. I'm going to add a half circle. Single pi n. Because if I add, of course, 180, now I'm in 4. 180, back to 2. 180, 4. So that's how you can do that with the shortcut. As always, you are welcome to do the answers in all 4 quadrants and put plus 2 pi n on them. It's a little obnoxious, I personally think, but I just want to do one with the shortcut from the very beginning, okay? Just to review that. All right, here we go. Find all the solutions 0 to 2 pi. So first off, 0 to 2 pi in radians. Do I have to do the coterminals? That's what we got to know. Nope, we're limited to 0 to 2 pi, 1 circle, no coterminals necessary. All right, well, this is kind of fancy, not really. So we've got signs on both sides of the equations. We probably want to get them on one side. So I'm going to go ahead and add this one over and we'll combine them. So let's see where we're at. We just got to do a little algebra here. 1 sign, another sign, 2 signs. I got my root 2. We're at 0 now on the right. I'm like, oh yeah, I can solve that for sine of x pretty easy. I'm going to subtract my root 2 over, and I'm going to divide off the coefficient of 2 in the front. You guys can just do that. And right now, I'm already instantly thinking you're on which triangle? 40. You got it. All right, let's do it. So a little more algebra today to solve for sine, but I don't think that's a big deal. All students take calculus. Now, notice, of course, we're negative over here on our fraction, so we're eliminating our a and s, because sine's positive in a and s, so we're going to draw in 3 and 4. I'm going to start in 3. You already told me 45. If you want to label the sides, go for it. If you do sine, of course, opposite hypotenuse, you'll have -1 over 2, which does rationalize out. Let's measure from 0. So we're 45 past the 180 line. So what's your answer? 225 in degrees. I already hear it. Now put that into radians for me. What's that in radians? goes quiet. Yeah. You can do that one in your head. You're like, no, you can't. Yeah, I can. Because 45, you know, is pi over 4. We already know 45 degrees is a quarter pi. Pi 180, I just did pi plus a quarter in my head, 1 1/4. Mental math, fractions, right? We love fractions. Okay, I don't love fractions. So I know 45. Let's measure from 0. So you're 45 short of a full circle. So what's your degrees answer? 315. Now with no calculator, this is going to be good, I can sense it. A full circle is what in radius? 2 pi, and you're a quarter pi short. What's 2 minus a quarter? 7/4, 1 3/4, 7/4 pi. No calculators needed. Okay, so again, I really didn't teach you anything new or fancy on this one, just the fact you had to do a little algebra over here on the left to get sine of x alone. Just looking at which ones I'm going to skip. I forgot which numbers. Okay, let's look at B. Ooh, B. Here's what I don't like about B. You have different trig functions in them, secant and tangent. So here's where our identity sheet's going to help us. Now, first thoughts, I'm like, oh gosh, I could make 1 over cos. I could do 1 over cos plus sine over cos. I got a lot of fractions. I don't know if I love that necessarily. I do know on my identities, look in Pythagorean, secant and tangent are related in your Pythagorean identities. But remember, all those Pythagoreans have squared in them. So I need some squaring. Well, can you square both sides of an equation? Yeah, sure. I can do whatever I want. But my first thought was like, oh, if I square the left, I'm going to have to FOIL it. I feel like I'm going to have a lot of terms in it. Okay, I don't love it. So what I'm going to do is I'm going to isolate. I'm going to get one of these trig functions alone first. I'm just going to subtract tan x over there. Because I'm trying to work smarter, not harder, and make this not such a mess. So I'm like, okay. Now let's see what happens. And again, you could have subtracted secant. It doesn't matter. I just got one of them along. I'm going to square both sides. So that's going to turn into secant squared. This is a little obnoxious because I'm going to have to FOIL that out, but I'll do it. Now, some of you I know do not have to write this down twice and FOIL it. You can do it in your heads. I'm going to write it because you know I can't help myself. So let's take a look and see what we got over there. So I'm just FOILing distributing. Jacob.
Since it's a negative.
Say that again.
For
They're the same though. We've got quantity squared, so 2 of the same. Yep. All right, start FOILing. 1 and 1. Now let's do our middle terms here in our heads. Minus a tan, minus a tan. So minus 2 tans. And then negative tan, positive tan squared. Okay. All right, let's use some identities here now. So you got a couple of choices on this. It really doesn't matter. You'll get the same thing. So one of the things that jumps out to me is we have tangent squared plus 1, which is an identity. But I kind of think I want to swap this one out because we like to work in the main 3 trig functions. I like tangent. I like that. I don't love secant. So I'm going to use an identity for this one. So look on your identity sheet under Pythagorean. What is secant squared? It was just on your quiz. What does secant squared equal? Got it. So that's right off my sheet. Now, it looks like we're making this worse, but I think actually I just made it better for you. So this one's a little dicey because you have those different trig functions. And I don't know if you just magically think, oh, I'm going to square. I'm like, oh, I like it. Because what happens to your tangent squareds? Gone. What happens to the ones? So we're looking pretty good here. So I really have 0 over here and negative 2 tan. Okay. Well, again, this is a lot of algebra. Just to even get it set up to get anywhere in your answers, I'm going to divide by negative 2, which you can mentally do that, I'm aware. So I'm down to tan of x equals 0. That's what I'm going to work on. Whew. So this is what I'm saying. They get a little spicier today with the different trig functions and having to use identities and whatnot. Now, that's easy. I mean, we did this here. So obviously 0 won't be a triangle. So we're going to use some of our quadrantal points. So I'm going to give you a second to think about it. We're going to label our points correctly.
You're staring right at me.
I was not.
Yes, you were.
I was not. We're going to label our points correctly, and we're going to know which one is sine and which one's cosine. I'm going to give you a second to do it. Poor Jake's getting bullied here. All right, so remember, unit circle, right one, up one, left one, down one. Now, next question, you've got which two trig functions on these ordered pairs? In which order? Give them to me in the right order.
Sine,
Cos and sine, alphabetical. How do you make tangent out of cos and sine? Sine over cosine. So if I do sine over cosine, what does that equal? 0, which is what we want. So that's a winner answer right there. What other point is going to be an answer? Top, left, or bottom? Left. Because if we do 0 over -1, we get 0 again. Final answers. What are the angles that correspond to these points? Let's do the right one first. Right one is what? 0. 0 degrees, 0 radians. Got it. Left point. Pi. 180. Pi. So, I mean, the solving part got pretty easy, but getting to that tan of x is 0 is a little bit of a nightmare, having to know the square, etc. Are a lot of these on the homework? No. There might be one of them. Okay? All right, let's look at C. Let's do C and D. All right, got end state. I like they're the same trig functions. I like we have all tangent. I don't love that they're on different sides. So I'm going to move the tan over here. I'm going to subtract it off. Now, can you combine a tangent cubed and a tangent? No, not like terms. I'm just going to write it all down. So I have 3 tan cubed minus tan. Okay. Now here is when you least expect it. It slaps you in the face. One of your favorite F words in math. I'm going to factor. What can you factor out of those two terms? What do they both have on them? Tan. I'm going to use tan as my GCF. So I'm going to have 3 tan squared minus 1. Now, as always, cringe a little. We're going to set each to 0. Now, there's always a method to the madness. Didn't I just solve this in the previous problem? So we're not going to redo all the work. I'm just going to click it back and steal the answers and write it down. Okay? Let's do this one. So again, to solve this one, I'm going to have to, of course, add the 1, and then I'll divide the root 3 off. So what am I writing with 3? I'm going to divide it. So I'm going to have tangent squared equals 1 over 3, and then we have to square root it. Does this seem a little familiar? Don't forget plus or minus, square root of 1, 1, and I'm going to leave that. Now again, just for the sake of our notes and expediency, we solved this in the last problem. We're not going to reinvent the wheel. I'm going to click it back. I'm going to steal those answers. I'm just going to write 0 and pi down. Now, that one too, always a method to the madness. Oh, didn't I start working on that here in the warm-up? Didn't we have, isn't that where I'm at right now on the problem we're on? So I'm going to start stealing these answers. But hold on a second. Our directions limit you to one circle. So that just means I don't need the pi ends. I'm not going to put those. But here's the gross part. I do need these other two, because there's 4 total answers really for this one. So first I'm just going to steal the pi over 6. I'm going to write that one down. Let me click ahead here. Pi over 6. I'm going to steal the quadrant 2 answer, the purple, the 5 pi over 6. I'm just going to write that one down. Now, we do have to, of course, get the other ones because we can't just use the coterminals. So if I put another 30 there, what's that one? Give me degrees first. 210, 180 plus 30, 210. Let's put 210. What is that in radians though? Yep. And again, some of you can get the 4th quadrant answer without even having to draw it. because you know you're 30 short of the full circle. So if you're 30 short of the full circle, you're in what for degrees? 330 more, and then we're going to put that in radians, 11 pi over 6. Okay. So I did steal these answers from some previous problems just to save us a little bit of working time. Okay, let's do D. All right, D is really not too tricky. First, my complaint is I don't like the different trig functions. You have a sine and a cos. I don't love it. But hey, this is on our identities that you just took a quiz on. What's sine squared, your Pythagorean identity? 1 minus cos squared. So let's use that. Bless you. So let's take a look at it and now see what we can do here. So I see the quadratic, the squared. I think I'm probably going to have to factor it again. I'm going to first get it in the correct order. The squared term first. I don't love that that's negative either. I'm going to put cos in the middle, and I'm going to go ahead and combine our like terms but ones. Now, this is me. I think it's hard to factor. I think it's easy to make a sign error when you have the negative. You could just switch them. I'm going to rewrite it, of course, so it looks pretty. I'm going to change all these signs. Okay. Trinomial, lead coefficient 1. I just have to know my times tables. What multiplies to -2 and adds to the middle of -1. -2 and 1. I like it. So just some good old factoring. And then, of course, like always, we set each factor to 0. So I'm just going to move to the top so I'm not clear at the bottom. So I would add 2 over. So I'm going to have to work on this. And then I'm going to subtract the 1 off. So I'll have cos x equals -1. Now, the 2. Because I'm like, looking at my special triangles here. 2, of course, would be, if we take a look, there's square root of 2, of course, on the 45, 45, 90. There's that on the 30, 60, 90. But I'm like, wait a minute. If I'm thinking about that in my SOHCAHTOA, my sides on the triangle, adjacent hypotenuse. Can your adjacent side be bigger than the hypotenuse? Sure can. Not a triangle, no triangle. Now I'm asking myself, could it be a quadrantal? Well, do we have 2 on any of the points on the quadrant? No, we can't do it. This is giving me big nothing. Okay. Now I might get an answer from this guy, so I'm not going full no solution for an answer. I'm going to think about this one. Now again, I'm thinking the same thing. Could it be a triangle? Could adjacent hypotenuse be the same? No, hypotenuse has to be bigger. I'm not ready to say no, though, because -1 is on our quadrantals. We just got to figure out which one. So we're going to label our ordered pairs in the correct order. No, I'm not looking at you, Jane. And we did, you're going to be so mad, we did all of this fun-filled work for one lousy final answer. Which point has a cos value of -1? Top, bottom, left, right. So we did all of that. What's the angle that goes to that point? Pi. That's a little depressing. That's a lot of work for pi, if you ask me. Whew. Questions on those. All right. Betty White says we're going to skip this because this really isn't helpful at all, really. It's not very helpful because it gives you decimal answers. We always want exact, and it's not in the homework. So in the spirit of Betty White, we're going to skip it. All right, last thing I have for you. This is easy. As always, there's one extra step. Notice the directions, solve the multiple angle equations. So radians, and coterminals are in play. Now, when it says multi-angle, we're talking about this. That is really the coefficient half x, half times x. Don't let that freak you out. It's the same process as always. Right now, I am focused on the fact, let me get my graph down here. I'm focused on the fact we have sine and 0. So is it a triangle? No 0 on a triangle. So it's the points again, the quadrantals. I'm going to mark the points. It's all of that. Right one. I feel like we've marked these a million times. It's getting obnoxious. Okay, you take a second. and you circle which point or points you think have a sign of 0. Top, bottom, left, right. Left and right, because sign remembers that second coordinate. Okay. What are the angles that correspond to these points? The right one is at what? 0. Left is at what? Now, here's our ready, new, exciting, sarcasm, fancy stuff we're going to do. Instead of me just writing x equals 0, x equals pi, okay, you have x over 2. So I'm going to put x over 2 equals 0. I'm going to come back to that, hang on. X over 2 equals pi. Now, also remember it says all solutions. I need the coterminals. So I also have to put on the 2 pi n's. Now here's your extra exciting piece of work. If you're going to get x alone, how do you get rid of over 2? So I'm going to just go through and multiply everything by 2. And then I shall list those answers. Okay, 2's cancel. I got my x equals, I don't know, 0 times 2 is what?
0.
Is that worth me writing? I don't really feel like it is. Okay, 2 times 2 pi n is 4 pi n. Okay, same thing, the 2's cancel. I'm going to do 2 times pi, and then 2 times 2 pi n. Got it. So that just adjusts your answers for you. When you divide those all by a half, by 2, you're back to your normal x equals y equals. So that's all you have to do is adjust for the answers at the very end to get x alone. Now, quick question. Could have you comboed this into a single answer? If you're a little more intuitive, you could have and done like 0 plus pi n and toggle back and forth, but whatever works for you. So let's just do a couple more of these. You can see these are simple. There's not a lot of factoring or craziness. We're just ready to go. Tan of x, again, I'm focused in on the tan and the 1. We'll deal with the 2x in a minute. Now, I think we can have triangles with opposite adjacent the same side. I'm going to label my all students take calculus, tan positive, and 1 and 3. So I'm going to label here, of course, TOA, opposite, adjacent. Hypotenuse root 2, we're on that 45. I'm going to go ahead and label this one too. 45. Okay. Now, let's give our answers here, of course. First off, I want them in radians. Now, you should know this one. This one's easy. What's 45 in radians? Pi over 4. So we're going to sit tight on that. I'm going to measure from 0 around. So you're at 180 plus 45. Or again, radians would be easy in our head. 180 is pi, a quarter pi more. What's 1 plus a quarter? 5/4, 1 1/4, whatever. Okay, so here we go. Now here's the dramatic part. Dramatic, totally. So I'm not going to write x equals. We're going to put 2x equals. I'm going to do the pi over 4 first and my coterminals. I'm going to come back. I'm going to deal with that in a minute. Now, my second answer was the 5 pi over 4, but I'm going to put 2x equals 5 pi over 4 and my coterminals. Okay, fancy fun-filled work. To get x alone, we're just going to run through and divide every single thing up here by what? 2. Okay, start dividing. Hopefully you're good at fractions. A lot of over 2's. Okay, so x equals, what's a quarter divided by 2? An 8. 2's cancel there. That was easy. Got it. So there's my first set of answers. What's 5/4 divided by 2? 5/8. And that's nice. Done. Got it. All right. Any questions on that guy? How about this? Should we skip C so we can get some time? We can do some of the homework ones together because it's more of the same, you know.